This is lesson 3.3 on synthetic division. Now, we've seen division before working with numbers. We've seen that hopefully fairly early in our math career. Well, just like dividing two numbers, we can divide two polynomials. We can divide one polynomial by another. And just like with regular numbers where we have a quotient and remainder when we divide two numbers, we also have a quotient and remainder when we divide two polynomials. The quotient in some sense refers to the whole part of the division, and the remainder refers to the fractional part. So if we have if we're dividing one polynomial by another, if the polynomial that we're dividing by is smaller, that means that we're going to have a whole part and a fractional part. And so again, the quotient is going to be that whole part. The remainder will be the fractional part. We'll revisit that idea later on when we talk about rational functions. Now, when we divide two polynomials, we've got two main options, really. We've got one way, which is called synthetic division, and another way that we call long division. Synthetic division is going to be the focus for this section, though we're going to take a look at long division as well. The focus of the drill problems are going to be synthetic division. The application problem, that's where we're going to see long division. Synthetic division, the main advantage of it is that it's very quick. It's extremely quick, especially compared to long division. The primary disadvantage, and it's a pretty big disadvantage, is that it only works when we're dividing by a linear term. So when the highest exponent, or really the only exponent of our x, is the first power. So we can't use synthetic division when we're dividing by quadratics or cubics or anything bigger. It's just linear factors. So that limits synthetic division quite a bit. Long division, as its name implies, is longer. It takes a lot more time. However, we can use it for any polynomial whatsoever. So for what it makes up for in convenience, or what it lacks in convenience, it makes up for in its usefulness. There are certain problems where it's really the only option. So we're going to take a look at synthetic division, see a couple examples of that for our drill problems, and then see one example of long division that we may see in our application problems. All right, so let's consider this problem. So find the quotient and remainder when 2x squared plus 5x minus 1 is divided by x plus 7. We need to pay attention to the numbers in what we're dividing into and what we're dividing by. In order for synthetic division to work correctly, this always needs to be in the form x plus or minus some number. So we don't need a coefficient here. It needs to be 1. If we had something other than 1, our two options would be to either divide everything in our problem, every number here and every number here, by that number, or to use long division, which we'll see later. So anything that we run into, I'm going to go ahead and give you in this form, so you don't have to worry about that. So the coefficient here should always be positive 1. So we need to pay attention to this number and the coefficients of the polynomial that we're dividing into. What we're going to do is we're going to take this number here, change its sign. So negative 7. I'm going to put that in a box. It's a special number, so we'll keep it away from the riffraff. Next, I look at the polynomial that I'm dividing into. I make sure that I've written this in descending order, so starting with x squared or x cubed, whatever the highest power is, and then I go down by 1 each time. Even if I've skipped something, I need to keep track of it. So for example, if I had an x cubed term and I skipped straight to x to the first term, I need to imagine that there'd be a 0x squared there. So keep track of every single power of x. Look at each coefficient and write down those numbers. Put down the exact number, so you don't need to change the signs here. So 2, 5, and negative 1. This is the coefficient of x squared, the coefficient of x, and my constant term. All right, so here's the setup for synthetic division. This first number here, not the one in the box, it's special. It just stays there. I'm going to just write it right here. It doesn't change one bit. Okay, now I take my special number, multiply it by this number. So negative 7 times 2, it's going to be negative 14. I'm going to write it under the next number in my first row here. Now I add these two numbers. 5 plus negative 14, that's going to be negative 9. Now I'll do it again. Negative 9 times negative 7, so that's going to be positive 63. Now I add them up. Negative 1 plus 63, that's 62. And that's it. I'm done. I need to interpret my results a little bit, though. These numbers right here, these correspond to the quotient from my division. And this single number here is going to correspond to my remainder. So my quotient, what I do is I look at my biggest power of x, or the polynomial that I was dividing into. I'm going to take one less than that. So my biggest power here is x squared. So my first number here corresponds to the coefficient of x in the quotient. So 2x minus 9. That's my quotient. My remainder, it's just going to be this number, 62. 62. Pen was lagging. There we go. That's our final answer. Our quotient is 2x minus 9, and our remainder is 62. All right, let's try another one. So find the quotient and remainder when x cubed minus 4x plus 5 is divided by x minus 2. So again, remember we look at the number, or rather the polynomial we're dividing by. We're going to change the sign and put it in the special box. So there's 2. Next, we look at the polynomial we're dividing into. It's in decreasing order. I'm just going to write the coefficients for each power. So the coefficient of x cubed is 1. I don't have an x squared term, so its coefficient is 0. I don't skip it. I've got to put that 0. The coefficient of my x term is negative 4, and my constant term is 5. So I bring down this first number, and I multiply these two. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 4 plus 4 is 0. 0 times 2 is 0. 5 plus 0 is 5. So again, this is our remainder. The last term is our remainder. Everything else corresponds to the quotient. So in this case, my quotient, previously my biggest power was 3, so this corresponds to a power 2 term. So I have 1x squared plus 2x plus 0, but I don't need to write that. And my remainder is 5. Okay, let's look at an example where synthetic division isn't going to work. So same instructions, we want to find the quotient and remainder of 2 when we divide two polynomials. So we're dividing into the polynomial x to the 4th minus 2x squared plus 4x minus 1, and we're dividing it by x squared plus 4x plus 1. So notice we are dividing by a quadratic polynomial. So this tells us that we cannot use synthetic division. So what we're going to do is we're going to have to use long division. So using long division, we're going to write out our usual long division sign. This is the long division sign that, at least in American schools, you might recognize for long division, for just numbers. Outside, we're going to put what we're dividing by, write it again in decreasing order, x squared plus 4x plus 1. And inside, we're going to write the polynomial that we're dividing into. It is helpful to not skip any powers of x. Just like we did with synthetic division, it's helpful when you're doing long division not to skip powers either. It's just to be careful. So here, see how we don't have an x cubed term? I'm still going to go ahead and write plus 0 x cubed. That's just going to help me out just a little bit. So minus 2x squared plus 4x minus 1. So what we're going to do is we're always going to compare the biggest powers of x. So here I have x squared, here I have x to the 4th. So I want to think, what is x to the 4th divided by x squared? So x to the 4th divided by x squared, that's going to be just x squared. Remember, when I am dividing two numbers with the same bases, this is 4. So here I have x to the 4th divided by x squared. I'm just going to subtract my bases, or sorry, subtract the exponents. 4 minus 2 is 2. So I want to put that number right here. So x squared. Now I multiply every number here by x squared. So x squared times x squared is x to the fourth. 4x times x squared is going to be 4x cubed. Notice I'm going to put it underneath my x cubed term from the original polynomial. And then 1 times x squared is x squared. So again, I'm going to write it under the x squared term. Now here's the primary difference. Well, not the primary, but one of the primary differences between synthetic and long division. Remember, with synthetic division, we added our columns up. Here we're going to subtract. So make sure you subtract things correctly. So x to the fourth minus x to the fourth is 0. You should always get 0 as your first term. If you don't, you messed up. Step back and make sure that you've chosen this number correctly. This times this should always be exactly the first term here. All right, 0x cubed minus 4x cubed. That's going to be negative 4x cubed. The negative 2x squared minus x squared, that will be negative 3x squared. Now I'm going to go ahead and bring down the next term. So bring down plus 4x. Now the process begins anew. I check to make sure that the power here is bigger than or equal to the power here. Once this power becomes smaller than this power, I stop. That's the end. Here it's bigger, so I'm going to keep on going. So I do the same process that I did before. Negative 4x cubed divided by x squared. So negative 4x cubed divided by x squared. Once again, same basis. I subtract the exponents. That's going to be negative 4x. So I put minus 4x here. And again, I multiply everything here by negative 4x. So x squared times negative 4x is negative 4x cubed. 4x times negative 4x is going to be negative 16x. Sorry, negative 16x squared. And 1 times negative 4x is going to be negative 4x. And once again, I subtract each of these. So negative 4x cubed minus negative, so plus 4x cubed is 0. Once again, these should cancel out. If they don't, we messed up somewhere. Go back and check your work. Negative 3x squared minus a negative, so plus 16x squared. So negative 3x squared plus 16x squared. That will be 13x squared. 4x minus negative 4x, so plus 4x. That will be plus 8x. And once again, I look up here and bring down my next term. All right, this power is 2. This power is 2. They're the same, so I'm going to keep going. So I want to figure out 13x squared divided by x squared. That's just going to be 13. So I'll write plus 13 here. And now once again, I multiply each of these terms by 13. So 13 times x squared is 13x squared. 4x times 13, 4 times 13, let's see here, that's going to be 52. So plus 52x plus 1 times, positive 1 times positive 13, that will be plus 13. And one last time, I'm going to subtract each of those. So 13x squared minus 13x squared is 0. Again, first column should always cancel out. 8x minus 52x, I believe that's going to be negative 44x. The negative 1 minus 13, that's going to be negative 14. Now notice, well, two things. Notice I no longer have anything to bring down, and the highest power of this is x to the first power. Over here, my highest power is x to the second power. This is a bigger power than this, so I stop. I'm done. What's the final answer then? This number up here is my quotient. This bit right here is my remainder. So my final answer is, my quotient is x squared minus 4x plus 13. And my remainder is negative 44x minus 14. So long division, again, it is significantly longer than synthetic division. but sometimes it's our only option. If for whatever reason we needed to divide this polynomial by this one, rather long division is our only option. Synthetic division we can only use when we are dividing by a linear polynomial. So this we will see on the application portion of our test. Synthetic division we'll see on the drill portion.